there is an ocean on this moon. Not a dried up lake bed, not frozen dust. A real liquid ocean bigger than every ocean on Earth combined. And it's been sitting there in the dark, completely alone, for 4 billion years. The question isn't whether we should go. The question is, what are we going to find when we get there? Europa, one of Jupiter's 95 known moons. It looks harmless from space, beautiful even. A smooth white ball laced with reddish-brown cracks, like a cracked egg made of ice. But here's what most people don't know. Beneath that frozen surface, anywhere between 10 and 30 kilometers of solid ice, there's a saltwater ocean that's estimated to be 100 kilometers deep. For context, the deepest point in Earth's ocean, the Mariana Trench, is just under 11 kilometers. Europa's ocean absolutely swallows ours. And it has 3 things that scientists believe are the non-negotiable ingredients for life: liquid water, chemical energy, and time. Billions of years of it. So here's what happens if we actually go there. Getting to Europa isn't a weekend trip. Jupiter sits roughly 628 million kilometers from Earth at its closest. The fastest spacecraft we've ever launched, New Horizons, took over a year just to reach Jupiter. A crewed mission? With the technology we're developing right now, we're looking at 3 to 6 years of travel time. Just to get there. The crew would be living inside a spacecraft the size of a large apartment for years in the most radiation-soaked region of our solar system. Because here's the thing nobody puts in the brochure. Jupiter's magnetic field generates a radiation belt that bombards Europa's surface with the equivalent of 5,400 rems per day. A lethal dose for a human is around 300 to 500 rems total. You step outside unshielded on Europa, you're dead in hours. So before the boots even hit the ice, the engineering challenge is unlike anything humanity has ever attempted. The landing craft would need radiation shielding so thick it barely resembles anything we've built before. Every system. Backup of a backup of a backup. Because there is no rescue mission coming. You are 888 million kilometers from the nearest hospital. The moment the lander settles onto Europa's surface, that first boot print in the ice, it would be the single most significant moment in human history. More significant than the moon landing. Because we would be standing on a world that almost certainly contains something alive. The surface is surreal. No atmosphere to speak of. Gravity, just 13% of Earth's. You'd feel almost weightless. Jupiter dominates the sky. Massive, swirling, impossibly close. It never sets. It just hangs there. And the ground beneath you, it hisses. Those red-brown cracks you saw from space, they're called lineae, fractures where the ice has been pulled apart by tidal forces from Jupiter's gravity, then flooded with warmer, mineral-rich water from below and refrozen. Some scientists believe those cracks might be recent, geologically recent, which means the ocean below isn't static. It's active, moving, churning. And here's the open loop you need to hold on to. Something might be churning it, but we'll get there. The mission's main objective: get through the ice. The plan, which NASA and ESA engineers have already been seriously working on, involves a nuclear-powered cryobot, a torpedo-shaped probe that melts its way downward through the ice over the course of months. Slowly, millimeter by millimeter, through 20 kilometers of solid ice. And the whole time, the crew waits. Imagine being one of those astronauts. You've traveled 6 years round trip to reach this place. You're sitting on the most dangerous moon in the solar system. Radiation clocks are ticking. Supplies are finite. And you're just waiting. Watching the drill go down. Wondering what it's going to hit at the bottom? After weeks, maybe months, the cryobot breaks through the final layer. And for the first time in the history of the universe, as far as we know, a human-made object is floating in an alien ocean. The submarine camera sweeps across the ocean floor. And what scientists expect to find, based on what we know from Earth, are hydrothermal vents. Cracks in the seafloor where scalding, mineral-rich water erupts from the rocky interior, driven by the same tidal heating that keeps the ocean liquid. On Earth, hydrothermal vents were once thought to be dead zones, too hot, too dark, too extreme. Then we sent cameras down and found ecosystems, thriving, crawling, complex life, tube worms, shrimp, microbes, living without a single ray of sunlight. Europa could have those vents. Europa almost certainly has those vents. And then the probe picks up something in the water. Chemical signatures, organic compounds, things that shouldn't exist unless something is producing them. And then, just at the edge of the camera frame, the probe's sensors detect movement, not a current, not a geological tremor, intentional, directional movement. Now, let's be clear, we don't know what that is. That's the moment every scientist on the mission would stop breathing for a few seconds. But consider this. If there is life in Europa's ocean, even microbial life, it will be the most world-altering discovery in the history of our species. It means life doesn't just exist on Earth. It means life is not a miracle. It means life is what the universe does when the conditions are right. And if conditions can be right on Europa, they can be right on thousands of other moons, circling thousands of other planets, around thousands of other stars. We would go from being alone to being one voice in a cosmic crowd. But here's what the excitement makes us forget. Even if the mission is a perfect scientific success, the crew might not make it home. The radiation exposure alone sets a hard clock on surface operations. Every hour outside the shielded habitat is hours off someone's life. The long-term effects of multi-year deep space travel on the human body: bone density loss, cardiovascular damage, immune degradation, are still being studied. And communication with Earth? There's a delay of up to 52 minutes one way. If something goes wrong, you can't call for help. By the time Houston hears your distress signal, the situation is already 52 minutes old. These astronauts would be the most isolated human beings who have ever lived. More isolated than any explorer, any sailor, any castaway in history. And yet, they volunteer for it, all of them. Because some questions are worth risking everything to answer. Here's the thing about Europa. It's not just a moon, it's a mirror. When we look at Europa, we're forced to ask if life can exist there, in the dark, under kilometers of ice, with no sunlight, no warmth from a star, in an ocean that's been sealed for billions of years. Then maybe, just maybe, we're not the exception. Maybe life is normal. Maybe Earth is just one of the places where the universe got curious about itself. NASA's Europa Clipper spacecraft launched in October 2004 and is already on its way to Jupiter right now. It will arrive in 2030 and begin studying the moon in detail. Every single piece of data it sends back is a step toward that landing. That moment, that first boot print on the ice. It may not happen in 10 years, maybe not 20, but it will happen. And when it does, when that camera breaks through the ice and the lights flicker on in an alien ocean for the very first time, the universe will have its answer. And so will we. If this blew your mind even a little, you already know what to do. Hit subscribe, because we're covering every major space mission this decade, from the Europa Clipper flyby data to the first crewed Mars missions. And you don't want to miss what comes next. And drop a comment below. Do you think there's life on Europa? Microbial slime? Something bigger? Or nothing at all? I genuinely read every comment. Let me know.